All right, in this video, we are going over the normal curve. So I will type this up and then you can grab it so that you can take notes and follow along. The normal curve symbols are that it's called mu for the mean and that weird looking O for standard deviation. And the mean should be at the middle. And we typically only go 3 standard deviations above and 3 standard deviations below the mean. And if you recall, the empirical rule says 68% of the data needs to be between 1 standard deviation of the mean and then 2 standard deviations of the mean is 95%. And then within 3 standard deviations of the mean is 99.7. So if you're asked to determine whether or not data is normal, you can calculate the percent of the data that's 1 standard deviation from the mean, 2 and 3, and check and make sure that it pretty much is balanced like this. You could also make a histogram, you could make a dot plot. All of those graphs show the shape beautifully. So if I gave you a set of numbers and I wanted to know if they were normal, the first thing I would do is graph them. So in these questions, we're actually calculating with the normal curve. We're not proving whether or not data is normal. All right, so we have an example. The mean height of men at UNCW is 63 inches, so that is the mu, with a standard deviation of 2 inches. So the first thing I'm going to do is sketch the normal curve. On a free response, if you have a normal curve situation like this, they expect you to draw it. So 63, 65, 67, 69, 61, 59, 57. All right, so those are my standard deviations. 1 standard deviation, 2, 3. 1, 2, 3 to the left. All right, find the percent of men who are greater than 67 inches. Well, 67 is one of my standard deviations. So I can use the empirical rule to figure out what this little bit left over would be. So what I would do is split each of these up, and we did this in class at one point, but 68 divided by 2 is 34, and then 95% minus the 68% that's in the middle, and then divide that by 2 means this block is 13.5, and then the 99.7 minus the 95, and then divide that by 2 is 2.35, 2.35, and then 100% of the data minus the 99.7, and then divide that by 2 is 0.15. So the percent of men that are greater, we can use the 2.35% and the 0.15% and just add those together. So 2.35 plus 0.15, it's only about 2.5%. All right, find the percent of men that are between 59 and 61. So again, those are 2 of my standard deviation numbers. So I've already kind of split this up, but that would be 13.5%. All right, we also have the z-score formula because not every single value in the data is going to be an exact standard deviation. So the z-score tells us basically what standard deviation our individual data is in between. So find the z-score of a man who is 66.2 inches. So the z-score is what I'm solving for. The x stands for the number that you have in your data set, minus the mean, which was 63, divided by the standard deviation, which was 2. So I'm just going to type that in the calculator. And I got 1.6. So 1.6 is somewhere in between 1 and 2, so that should make sense because 66.2 inches is in between 65 and 67 inches. So that is my z-score. All right, now the calculator, you can use the calculator whenever. You can use it for the empirical rule, but you have to use it if you have numbers that are not exactly 1, 2, or 3 standard deviations away from the mean. So I don't have a context to this because I don't want this video to be too long, but I'm going to sketch my curve. So my mean is 72 and my standard deviation is 5.6. So I am going to do this quick just so I can visualize. So 3 above, 3 below. So you can see 62 is not an exact standard deviation. It would be somewhere in here. So if it was multiple choice, I might be able to estimate with that percentage. But we're going to have to use the normal CDF to find the area that is to the left of that. You could also use the z-score formula to find the z-score and then use the z-score table to find this answer as well. But we're going to hit second vars and choose option 2. Second vars, option 2. So the default setting on the calculator is to shade the area to the left. So that's why my lower bound is -1 E99. It basically is like -1 times 10 to the 99th power. So that's like practically negative infinity. It's -1 with 99 zeros. The upper is going to be the 62 that I'm looking for. Now your lower and your upper are not always going to be, like you're not always going to have this for your lower. If I wanted to go in between 58 and 62, then my lower would be 58. You have to know the mean and the standard deviation, and then we just type that in. So 0.037 is 3.7%, so that would be my probability. All right, so find the probability of choosing between 64 and 76. So again, my second var is option 2. This time I'm going 64 is my low and 76 is my upper. So 0.686, so 68.6%, and 64 would be somewhere in here, 76. So that should make sense that it's somewhere close to 68 because it's close to being 1 standard deviation away in both directions. All right, so that's normal CDF. We use it when we're finding percentages or finding the probability less than, in between, or we could also do greater than. All right, situations where we have to use that z-table is when you're solving for the mean, or you could be solving for the number or the standard deviation, but basically there's no way to get around doing this in the calculator because you need the mean and the standard deviation before the calculator can do anything. So in this situation, I have the standard deviation is 5.2. And I know that 15% of the data is greater than 24. So 24 is the number that I'm looking for. 24 minus, I don't know what the mean is. So here's why I need the z-table, because there's nowhere to put 15% in this formula. But I can look for 15% on my z-table, and then I can have a number to plug in, and then I can solve this for the mean. So 57% of, or 15% of the data is greater than 24. So you kind of have to know, like, this is 50%. So 15% is greater than, it's a very small percent, so my tail is to the right. So I'm going to use this one. And basically what my table is going to show me is the shaded area. So I'm looking for greater than whatever this z-score is going to be 15%. But since it's only showing me this shaded region, then I'm looking for 85% on my z-table. So I'm just going to scan this whole table looking for 0.85 or as close to 0.85 as I can get. And it is like kind of in order. So it looks like these two are my closest to 0.85, and I am actually going to subtract those from 0.85 to see which one is the closest. All right, so this one is 0.015 away. This one is 0.0008. So this one is closer. So I'm going to use this one. So 0.8508. I'm going to go back to where I have my formula, and I'm going to put 0.8508 in place of z. All right, and now I'm just going to solve this for the mean. So I'm going to multiply both sides by 5.2. And then I'm going to subtract 24. And then divide both sides by -1 so that my mean is positive. So my average for whatever this context was, my mean was 19.576. All right, but I have to use the z-table. And you have two choices. I needed this one because I know that where it said 15% of the data is greater than 24, it's like 24 is here and 15 is such a small percent. I know that this is 15. This table would be used if I had said 15% of the data is less than, because now I know 15% is on the smaller side to the left.